Welcome. Let's try to solve another Leetcode problem 26. Remove duplicates from sorted array. So for this problem, we need to solve it in place. So we are giving an integer array sorted in non-decreasing order. So this is the integer array. It is sorted in non-decreasing order. As you can see, it is increasing, but there's a duplicate element. And we need to remove the duplicates in place. So this means we're gonna have the unique element. Yeah, so let's just use the first example. So for example, we have this array 1, 1, 2, and because this 1 and 1, it is a duplicate element, so it is gonna be 1 and 2, and we need to return the index, which is the next index. So because this is 1, this is 2, so we're gonna return the next index, which is gonna be 2. But we need to solve the problem in place. So this means we cannot copy the nums array. So for example, we cannot use a set, and by using a set, we find how many unique elements, and the result is gonna be the length of the set L plus 1. We cannot solve it like that. We cannot use actual memory. We must solve it in place. So this means we can just use some pointers to solve the problem. So for example, we're gonna define a pointer, but we're gonna be the starting point. We need to check the length of the nums array. So the length of the num array is gonna be at least 1. So this means for the position, if we define the position as k, it's gonna be at least 1, because we have at least 1 element, and this 1 element must be unique. So for example, this is a 1. Yeah. So our starting point is from k equals 1 at this position. But how can we find where this k is? So from the beginning it is 1, and now we need to check the duplicate element. So for example, if this 1 equal to this 1, it is okay. We don't need to do anything. But what if this 1 not equal to this 2? Yeah, so for example, this 1 equal to this 1, it is okay, but what if this 1 not equal to this 2? So what gonna be the place of the k? So definitely, if it is not equal, so for example, this 1 not equal to this number. Yeah, let me think about it. If this element not equal. Yeah, if we find this one not equal to this one, we're gonna be the place of the k. So the place of the k gonna be the So let me use another example, maybe 1, 2, 3, 4. So this is from the beginning, k gonna be at this place. So the index of k gonna equal to 1. Now we're gonna check the element, two neighbor elements. So for example, if 1 not equal to 2, and this 2 are not equal to 3, and 3 not equal to 4. Yeah, if they are equal, it is okay. We don't need to update the position. Yeah, so this means the k gonna be here if they are equal. But if they are not equal, we need to update the position. Yeah, so this is very clear, because if this one not equal to 2, we need to update the position to the next position, so k gonna equal to 2. So this gonna be the k. And next we're gonna compare this 2 and 3. If they are not equal, so definitely we need to update the place of the k to the next one. Yeah, because the beginning of the k just means all the previous elements before k are gonna be unique. So this is why if they are not equal, so definitely it is a unique element. So for example, we're going to compare 3 and 4. If they are not equal, so this means 3 and 4 must be unique element. So both of them are going to be unique element. So k going to be updated to the next position. So here going to be the k. So finally we're going to return the index of the k. So for this example, it is 4. Yeah. So this is the idea. But what if they are equal? So in this example, if they're equal, we just ignore that, because the definition of the k is just to check the unique element. If they are equal, it means a duplicate element. It doesn't matter. K gonna still hold the position, which is 1. Yeah, because they are equal, it doesn't matter. Now we're gonna check the next one. 1 to 2, they are not equal, so k gonna be updated to 2. Gonna be at this position, definitely. Yeah, up to now, this is okay. But inside of the array, it's gonna be return 1 and 1. But we need to return 1 and 2. How can we return 1 and 2 instead of 1 and 1? So this means if they are not equal, we need to take out this element. So for example, if they are equal, it is okay. If 1 not equal to 2, we need to take out this element 2, and we need to put it to the position of k. So this means 2 gonna be here, and k gonna be here. We just need to return k. So this is the basic idea. So the idea is very simple, but we still need to think about it. How can we write the code in place? Because in place it seems an easy problem, but actually it is not so easy. We must understand how can we find out the unique element. So let's define a variable k. K gonna be starting from 1. So k means before the index k, all elements are gonna be unique. So this is the idea. So k gonna be starting from here. This means before k, this one element must be unique, because if there's only one element, it must be unique. Okay. Now we're gonna check the element one by one. So we're gonna use the index I. So I gonna be starting from 1, because this is the current element. We're gonna start from this one, and we're gonna compare with the previous element, which gonna be I minus 1. So this is why I gonna be starting from 1. I gonna less than nums.length and I plus plus. Now we need to check, as I said before, if nums I not equal to nums I minus 1. So this means the two neighboring elements are not equal. So we need to update the k. Yeah. But before that, before we update the k, we need to put this element 2 in the right position. So the position is going to be k. So we need to put it in the right position, which means nums k going to be updated with the element which is not equal, which is going to be nums I. And then we're going to update the index k. Finally, we just need to return k. Yeah. So the coding is simple. I think it is simple enough. We just need to check. We're gonna loop through the array. We just need to check if two neighboring elements are not equal. So this means we've already found it. Yeah. Maybe we're gonna use another example. Example 2. So this is k from the beginning. If they are equal, it is okay. If they are not equal, so this means k gonna be updated here. So this 0 gonna be 1. If they are equal, this is okay. If the 2 is not equal to the neighboring element, so this means here k gonna be updated to this position, gonna be 2, and k gonna be updated to the next one. It's gonna be here. Yeah. Now let me just submit it to check, and just submit it to check if it can pass. Yeah, as you can see, it's pretty fast and pass all the